this video, we will learn how to find the monopoly output and price at the profit maximization. The question is, the demand curve and cost function of a monopolist are x is equal to 50 minus 0.5 p. X is the output and p denotes the price, and this denotes our demand curve, and c is equal to 50 plus 40x. This is our cost curve. We have to evaluate the output and price at the maximum profit. That means we want to find out the profit maximizing output and price. Okay, since we have the monopolist, for monopolist profit maximization requires, okay, and let me write it here, profit maximization requires that this monopolist equates the marginal revenue with the marginal cost. This is the profit maximizing condition in case of monopoly. Okay, having said that, we are being given this demand function, that is x, that is output, is equal to 50 minus 0.5, and let me write 1 upon 2 in place of 0.5. okay, p. Now since we need to find out the marginal revenue, we should know the total revenue first. So first we need to find out the total revenue. To find out the total revenue, we solve this equation for p. That is, we want to find out the inverse demand function first. Transposing this minus 1 upon 2 p to LHS, it will become plus 1 upon 2 p is equal to 50. This transposing to the RHS, it will get subtracted. Okay, now multiplying both sides by 2, so this 2 and 2 will get cancelled, or let's write it simply, p will be equal to, so if I transpose it here, 2 50s are 100 and 2 into x is 2x. This is our inverse demand function. Okay, since we need to find out the total revenue, so we know that total revenue is equal to the price times output. Okay, so p is this very function, so in place of p I can write like this, 100 minus 2x, to this we multiply x. So our total revenue will be equal to 100 into x is 100x minus 2 into x is 2x square. Okay, so this denotes our total revenue function. Now we can simply find out the marginal revenue function. And what is marginal revenue? Marginal revenue, and let me write it here, marginal revenue is simply equal to the derivative of total revenue function with respect to output, that means dx. So we differentiate this demand function, rather this total revenue function, with respect to x. Derivative of x is 1, so we are left with 100, minus derivative of x square is 2x, so 2 into 2 is 4x, so we will get 4x. Okay, using power function rule. So marginal revenue is equal to 100 minus 4x. So we are done with the marginal revenue function. Now we need to find out the marginal cost function. So let's write the cost function that is being given as a c is equal to 50 plus 40x. And what will be the marginal cost? Very simple. Marginal cost is the derivative of the cost function with respect to output. Okay, so differentiating this function with respect to x, derivative of a constant, we know it is 0. Derivative of x in the second term is 1, so we are left with 40. Okay, now using profit maximizing condition, so profit maximization requires that we equate the marginal revenue with the marginal cost. Okay, so marginal cost is 40 and marginal revenue is 100 minus 2x, minus 4x, this very function, and we equate it with the marginal cost, which is equal to 40. Now we solve for x, transposing this x here, it will become, so we will get 100 minus 40 basic mathematics here. It is 4x, so we will get 4x is equal to 60 or x is equal to 15. So this is our profit maximizing output. Okay, what is the profit maximizing price? So simply plug x is equal to 50 into the inverse demand function in this equation. So we will get profit maximizing price equal to, so in place of x we have 15 this time, so this comes out to be P will be equal to 100 minus 30, which is equal to 70. Now let's try to graph this. Okay, that will make more sense. Let's draw a simple simple graph here. Let us say output is on the horizontal axis and price is on the vertical axis. Now if I draw this inverse demand function, it is price rather, okay, its price intercept is here 100, so we have 100 here, and it is sloping downwards. So we will get this demand function, what we call the average revenue function. This is our average revenue function. Now what is our marginal revenue function? You can see marginal revenue function has the same intercept as that of the average revenue function, but its slope is twice the slope of the average revenue function, that is inverse demand function. So we will draw it like this. This is our marginal revenue function. And what's marginal cost? Marginal cost is constant here. Okay, so let's draw it here. Let us suppose we have marginal cost is equal to 40. So let me write it here. This is our marginal cost function. Here it is 40. Now profit maximization occurs where marginal revenue and marginal cost intersect with each other, that is this point. Okay, so corresponding to the intersection point we have an output level of 15, and similarly we can find out corresponding profit maximizing price, which will be equal to, since AR is our inverse demand function, so P will be equal to 70, which we calculated. I hope I make myself clear in this video. So I request all people, please share, subscribe this channel with your friends. That's